NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the single phase, half wave and full wave rectifiers from power lines concepts. If you listen this video fully, you can solve this any type of questions from the single phase, half wave and full wave rectifiers. So let me discuss. To solve these questions from these concepts, you should know some formulas. If you know this formula, you can solve these questions very easily and quickly. So first formula is the calculation of average voltage is equal to 1 by period integration of alpha to beta Vm sin omega t d omega t. Is a basic formula. The limit is alpha to beta. Period, the value period and alpha and beta is depends on the type of rectifiers. Okay. So if you simplify this expression, we can get Vm by period cos alpha minus cos beta. Just remember this formula. So V net average is equal to Vm by period into cos alpha minus cos beta. Alpha beta is limit. Okay. This is general formula for all the type of single phase rectifiers. Second formula is the RMS output voltage calculations. V net RMS is equal to Vm by root of period 1 by 2 beta minus alpha minus 1 by 4 sin 2 beta minus sin 2 alpha the whole power 1 by 2. Okay. Remember this formula. If you don't remember this formula, if the question is asked for the calculation of RMS voltage, we have to simplify this integration. The simplification of integration takes some times. It will confuse you. If you remember this formula, just simplify this equation, we can get this answer. So remember both this formula. Third formula is what delivered to the load means, if the load is R load, the power is equal to I naught square RMS into R. This is RMS current. R is equal to B naught square RMS by R. Or otherwise you may write V naught RMS into I naught RMS. To the RL load means the inductive. For the inductive power, the average power consumed by the inductive load is 0. So the power delivered to the RL load is equal to power delivered to the R load, because the average power consumed by the inductive load is 0. Okay. So P is equal to I naught square RMS into R. Same formula is equal to V naught square RMS by R is equal to V naught RMS into I naught RMS. The fifth formula is power delivered to the RLE load means P is equal to, for R load, I naught square RMS into R. For inductive load, average power consumed by the inductive load is 0. For E load, I naught average into E. This is average value. Okay, power delivered to the RLE load. Next, 6. Power factor calculations. For the rectifiers, the input source power is equal to output load power. So input source power means Bs RMS, Is RMS into cos pi is equal to power delivered. Maybe power delivered may be R load or RL load or RLE load. So from that, the power factor cos pi is equal to power delivered divided by Bs RMS into Is RMS. The formula is if the load current is constant, the output load current is continuous, ripple free, constant current means I naught average is equal to I naught RMS. For that case, no need to find the RMS value. Just we go to find the average value. So I naught average is equal to I naught RMS. So V naught RMS is equal to V naught average. Okay, if the load current is constant only. The eighth formula is for single phase, half wave and full wave rectifiers, the source current is equal to load current, because so for a single phase, half wave or full wave rectifiers, input source, then the rectifiers, diodes, then load, all are connected in series. So source current is equal to load current. Is average is equal to I naught average. Is RMS is equal to I naught RMS. Then ninth formula, diode or thyristor current calculations. We know that diode or thyristor conducts 180 degree for out of 360 degree. So ID average or IT average, okay, is equal to I naught average into 180 by 360, because each diode conducts 180 degree out of 360. Okay. ID RMS is equal to I naught RMS into root of 180 by 360, because RMS value. 10th formula, inductive load only will give the constant continuous current. So if the load is constant means we go to assume the load will be RL load if the type of load is not given. So if the type of load is not given, we have to use the R load formula. These are the general formula for the single phase, half wave and full wave rectifiers. Then for the half wave diode rectifier with the R load, from the name itself we can find the parameters. If you know the limit alpha and beta, then we can find all other parameters, average output voltage, average current, RMS output voltage. We can find all the parameters if you know the limit alpha and beta, then okay. So if the half wave means period is equal to 2 pi. Remember that half wave means period is equal to 2 pi. Diode means alpha is equal to 0, because the conduction angle starts from 0 degree for the diode. Diode means alpha is equal to 0. R load means beta n with pi. Okay. So now we can find the average value. Just substitute here. This is the formula. So alpha value is known, beta value is known, period value is known. So we can find the V naught average. Similarly for V naught RMS. Okay, this formula is known. By substituting the value, we can easily find the average and RMS value. But you should remember this formula. Okay. Then formula for the half wave diode rectifier with R load. Half wave means, from the name itself we can define. Half wave means period is equal to 2 pi. Thyristor means alpha starts with alpha, firing angle. For the diode, conduction angle starts from 0 degree, so alpha is equal to 0. But for the thyristor, conduction angle starts from firing angle alpha, so alpha is equal to alpha. For R load, beta, the limit end with pi. Okay. So R load means beta is equal to 5. So limit and period is known. From there you can find V naught average, V naught RMS and all other parameters. Then half wave diode rectifier with R load. Half wave means period is equal to 2 pi. Diode, so conduction angle starts from 0, so alpha is equal to 0. For RL load, beta is equal to beta. Beta value is given. So from there we can find average output voltage, RMS output voltage and all other parameters. And half wave thyristor rectifier with RL load. Half wave means period is equal to 2 pi. Thyristor, so alpha starts from firing angle, end with, for RL load, end with beta is equal to beta. So the beta value and firing angle value all are given. So from that we can find all other parameters. Okay. Next, full wave diode rectifier with R load. Full wave means period is equal to pi. Half wave means period is equal to 2 pi. Here diode means alpha is equal to 0 degree. Thyristor means alpha is equal to firing angle alpha is given. R load means beta is equal to pi, but RL load means beta is equal to beta. For discontinuous conduction, half wave rectifier is a discontinuous source, discontinuous conduction, so beta is equal to beta. Then full wave thyristor rectifier with R load. Full wave, so period is equal to pi. Thyristor, so alpha is equal to firing angle alpha. R load, beta is equal to pi. Next, full wave diode rectifier with RL load. Full wave means period is equal to pi. Diode means alpha is equal to 0. RL load, for continuous conduction, if it is a continuous conduction, beta is equal to pi plus alpha. Okay. If it is a discontinuous conduction, for RL load, beta is equal to beta. Half wave rectifier is a discontinuous conduction, so beta is equal to beta. But here this is a continuous conduction, so beta is equal to pi plus alpha. Remember that. Okay. For RL load, if it is a discontinuous conduction, beta is equal to beta. For RL load, it is a continuous conduction, beta is equal to pi plus alpha. So then, full wave thyristor rectifier with RL load. Full wave means pi. Thyristor means alpha starts from firing angle alpha. RL load is a continuous conduction. For full wave rectifier is a continuous conduction rectifiers. So for RL load, beta is equal to pi plus alpha. Next, RL load with freewheeling diode. if freewheeling diode is used, the freewheeling diode eliminates the inductive load effect. So the RL load will act as equal to R load. So for half wave diode rectifier with RL load and freewheeling diode means, for half wave period is equal to pi, diode alpha starts from 0, but here alpha RL load is given, beta means beta, but the freewheeling diode is used. So the freewheeling diode eliminates the inductive load effect, that is equal to R load. So R load means beta is equal to pi. Okay. Next, half wave diode rectifier with RL load and freewheeling diode. Half wave means period is equal to 5. Pi resistor means alpha is equal to alpha, firing angle. RL load means beta is equal to beta, but here additionally freewheeling diode is used. The freewheeling diode eliminates the inductive load effect, so it will equal to R load. R load means beta is equal to pi, so beta is equal to 5. Then full wave diode rectifier with RL load and freewheeling diode, similar concepts. For full wave means period is equal to 5. Diode rectifier, the limit alpha starts from alpha, firing angle. For RL load, beta is equal to pi plus alpha, continuous conduction, so beta is equal to 5 plus alpha. But here freewheeling diode is used. This freewheeling diode eliminates the inductive load effect, so it equal to R load, so beta is equal to 5. Next, full wave diode rectifier with R load and freewheeling diode. Full wave means period is equal to 5. Diode means alpha is equal to 0. R load with freewheeling diode, so it is equal to R load, so beta is equal to 5. Next, full wave semiconductor. Semiconductor means for full wave 4 diodes or 4 thyristors are used. Here full wave semiconductor means 2 diodes and 2 thyristors are used. The diode also acts as the freewheeling diode effect. So the RL load, the L load effect eliminated by the diodes. Okay. So for semiconductors, the inductive load effect will be eliminated. So for full wave semiconductor with R load, full wave means period is equal to 5. For semiconductor, here thyristors are used, so alpha is equal to alpha, but there is a diode freewheeling effect, so the L inductive load effect will be eliminated. It is equal to R load, so beta is equal to 5. Okay. Next, for RLE load, there is some tricks to solve this problem in easiest manner. Instead of finding the average output voltage first, you should find the average output current. Then only solution for this problem will be easiest one. So if the load is RLE load is given, the first step is you have to find the average output current instead of average output voltage. So the average output current is equal to, so here period for half wave rectifier, period is equal to 2 pi, so 2 pi, or limit alpha is alpha into beta, limit alpha to beta. So alpha, for if the rectifier is diode rectifier, alpha will be 0. If this diode rectifier, alpha will be firing angle. Here this is a discontinuous, half wave always discontinuous conduction, so beta will be beta. Instead of Vm sin omega t, the value will be Vm sin omega t minus E, because at the output side the voltage, there is an voltage E. So the resultant voltage will be Vm sin omega t minus E. Okay, remember this formula. The second step is the calculation of V naught average. So we know that V is equal to IR, so V naught average is equal to I naught average into R plus E, the voltage at the output side. If you apply the KVL, we can get this formula. Remember that the first step is calculation of average output current, then the average output voltage. Okay, for discontinuous conduction, half wave always discontinuous. Okay, so this use these procedures. Second, full wave rectifier with RLE discontinuous conduction. This discontinuous conduction means the first step we go to find average output current. Here this is a full wave, so period is equal to pi. Here limit is alpha to theta. The rectifier is diode rectifier means alpha is equal to 0. If the rectifier is diode rectifier means alpha is equal to firing angle alpha. Here this is a discontinuous conduction, so beta will be beta. Okay, remember this formula. Second step is we go to find the average output voltage by using this formula. Okay. Third one, for full wave rectifier with RLE load continuous conduction. If it is a continuous conduction means the E will not affect at the output side. Okay, it is a continuous conduction, so output follows the input all the time. So there is no effect by the E load. So the RLE load is equal to that of RL load. So we can find the easily average output voltage by using the formula of average output voltage for RL load formula. RL load means for full rectifier, period is equal to 5, alpha is equal to, if the diode rectifier means alpha is equal to 0, TANCET rectifier means alpha is equal to alpha. L means for continuous conductions, so beta will be pi plus alpha. Okay. So second step, we may find the average output current by using this formula. So I naught average, this formula, same formula. I naught average is equal to V naught average minus E by R. Okay. If it is a continuous connection, you may use this procedure. Remember this procedures. Okay, for RLE load. If you remember this concept, we can solve any type of questions. Okay, let me solve a problem. Note that another one point, if the input voltage is given, that is not specified, maybe a RMS value or peak value or peak to peak, that parameter is not specified. We have to consider that voltage will be RMS voltage instead of peak value. Okay. So the relations between RMS and peak is equal to VRMS is equal to Vm by root 2. Okay. The first problem. The question is, as in GATE 2022 examinations, objective. Here the single phase full bridge rectifier is given, load is given, R value is 50 ohm, 200 volt, input voltage is equal to 200 volt, 50 gets is given. Okay, we go to find the active power drawn by the load, R load. Okay, so here this 200 voltage is not specified. This is, so we have to consider the voltage will be RMS voltage, not a peak voltage. Okay, so for power P is equal to drawn by the R load, V naught square RMS by R. Okay, we know the V naught RMS formula. So V naught RMS is equal to, formula is equal to, we know that this formula. Here full wave rectifier. So full wave rectifier means period is equal to pi alpha. Diode rectifier, alpha is equal to 0. Beta, here this is R load, so beta is equal to pi. Then Vm value, here input RMS value is given, so Vs RMS is equal to 200. We know this relations between, but we need the maximum voltage, maximum input voltage. So we know the relations between RMS and maximum voltage. From this relations, Vm is equal to Vs Vrms into root 2. So Vrms value 200. This given voltage will be RMS voltage. Okay, not a peak value. So 200 into root 2, we will get. Substitute this all these values in this equation, will get V naught RMS. V naught RMS is equal to 200. If you know the V naught RMS R value, we can easily find the power delivered. So power delivered is equal to 200 square by 50 is equal to 800 watts. Okay, this is the solution. The second question. This question is asked in GATE 2019 examinations. Here this given parameter is single phase fully controlled thyristor converter is given. Average output voltage is given 180 volt. The load current 10 amps is given, constant current. Input voltage is given 230 volt. Okay, this is not the peak value, RMS value. Okay, we have to find the power factor. So what will the power factor value? Power factor is equal to power delivered by Vs RMS and Is RMS. Okay, we have to find the power delivered. The load will be R load. Okay, so here E load is not given, so power delivered is equal to V naught RMS into I naught RMS. We go to find the V naught RMS and I naught RMS, but here note that load current is constant. Load current is constant. Constant means I naught average is equal to I naught RMS. So value is equal to 10 amps. Okay, if it is a current is load current is constant means average is equal to RMS. So I naught average is equal to I naught RMS is equal to 10. Okay, next V naught average is equal to V naught RMS. Average value is given, average voltage 180 is given, so 180. We can find the power delivered from these relations. Then Vs RMS, their input is given 230 volt. Vs RMS is given 230 volt. ISRMS for single phase rectifier, source current is equal to load current. So ISRMS is equal to I naught RMS. Okay, ISRMS is equal to I naught RMS. We know the formula, general formula. Source current is equal to load current for single phase rectifier. So ISRMS is equal to I naught RMS. Here 10 amps is given. All these parameters known. Substitute here, will get the power factor cos phi is equal to 0.78. This is the answers. Next, do it yourself. Okay, remember all this formula, all these concepts. Try to solve these questions. The first question is asked in TNEB AE 2018 examination. The second question is asked in GATE 2019 examinations. Third question is asked in GATE 2018 examinations. You can solve. If you know these concepts, given concepts very clearly, definitely you can able to solve these questions. Answer is, for the first question, answer will be equal to 0.78. For the second question's answer is equal to 81.66. For third question 90. Okay, check if you not get this answer, or otherwise if you have any doubts, just post your doubts through our NCM Learning WhatsApp group. We have an NCM Engineering Android app. In that app, all the materials, all the media materials are available. That is free for all. Just use it. It will definitely be useful for our examinations. Link is attached in the description box of the video. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.